Welcome to the Week in Italian Startup, where we discuss the latest highlights happening in the Italian tech and investment ecosystem. Today, Nicola and I have a special guest with us. We're here with Tommaso Migliore, the CEO of MDOTM, a company revolutionizing the investment landscape through cutting-edge AI technology. Exactly 1 year ago, we had the pleasure of discussing the challenges of investing in the ever-evolving tech industry. If you missed that episode, I highly encourage you to give it a listen. We delve into the dynamic nature of tech investment, highlighting the opportunities and the risk that come with it. It's fascinating how much can change in just a year, so be sure to check it out and see how our perspective may have evolved. So M.M is making waves in the investment war by developing explainable AI solutions that empower asset managers in their decision-making processes. They leverage state-of-the-art AI technology to create and optimize investment portfolios. It's an exciting endeavor that merges cutting-edge technology with the art of investing. So with that said, welcome, Tommaso.
Thank you. Happy to be here again.
Awesome.
Ciao, Tommaso, welcome.
So let's jump right into the meat of the discussion. So we've been seeing the rise of big LLM models, GPT-4, and everybody's talking about AI democratization. So there are even people kind of suggesting that right now every company has an opportunity to become an AI company. So it's really pervasive, and the big question right now on the table is it here to stay? Is it a hype? What are we looking at?
So, I mean, in our opinion, AI has always been here to stay. We started 7 years ago, and since the very beginning, we saw that this technology, compared to traditional statistical models, had the ability of being more flexible. And the flexibility represents the real differences, because flexibility means a wider spectrum of use cases, right? And so that's why since the very beginnings, we saw that AI was here to stay. What happened over the last 8 months, I would say, is been just that the world has been exposed suddenly through ChatGPT to this technology, having for the first time an understanding, a more clear understanding. The AI is not new. It's definitely not something that popped up over the last year. But what happened over the last year is that everybody, I think, could appreciate the difference from more statistical model or different math that was used before. In a very tangible way by interacting with this technology. The reason why everybody is referring to this moment as the democratization of AI, it's because suddenly this technology is accessible by a multitude of people, not necessarily just those who develop it. And one thing that I like to point out is how much this is not just ChatGPT, but it's really happening across industry, across the globe. I'm just going to tell you this story. If you think about it, every complex technology at the very beginning is used by the same people who develop that same technology. I always say, think about the Wright brothers at the beginning of last century. They were the one building the planes. They were the one flying the planes. 6 years ago, first computers, the people building the computer were the one using the computer, right? Nowadays, of course, there are people building, people using it, okay? With AI, it has been like that. Up until 8 months ago, the only people who could use AI were the data scientists, the researcher, the coders, the people really putting their hands in the code. Those were the user, right? No one else could use it. But then suddenly, what happened is that over the last year, we had about 100 new technology, if not more, that suddenly started popping up. Okay, and this is super interesting because just to give you an example, we talked roughly a year ago, I think, right? So if we talked a year ago, we did not have launched yet our own platform, which we launched, Sphere, which we launched in October 2020. Okay, if you think about it, Sphere, which is our platform that allows to autonomously integrate AI in your investment process, uses analytical AI, not generative AI. I can then explain what is the difference later. But if you think about it, we launched it in October 2020, okay? A month after that, ChatGPT got released to the public massively. And then Notion AI, and then Photoshop, and then many others. Now, it's not that this type of AI, it's not that you develop that overnight, right? So to launch it in October, we actually have been working for at least 12 months, if not 18 months, just to create the front end, the technology, and the interactivity to be able to launch it in October. That means that basically 1 year before, all the CEO of startup doing AI for real, they got to a sense in which, wow, this technology is getting mature enough so that the user can be other people and not just the developer of that technology. And that's why we were probably one of the first companies to develop this technology for the financial markets and release it to the public, and then ChatGPT, etc. And here we are 1 year later, or 8 months later, in which there's a ton of new technology that can be accessed all at the same time. This is really a proof that it's not just a ChatGPT phenomena. It's not definitely a hype of the moment. Maybe it could be perceived as an hype because everybody's talking about it, but it's really, if you look at it from an industry perspective, of an AI perspective, it's really a much broader phenomena that it's taking from healthcare to logistics to LLMs, et cetera, et cetera. So it's really it's a broad phenomenon, and therefore, there are all the clear indication that it's really here to stay.
Awesome. So I was curious. Let's talk about the crossing between AI and fintech. Is there can we identify maybe 2 to 3 core moments that are defining basically what is happening in the AI space? And then maybe we can talk about the different kinds of AI that are sort of present in the market. So what do you think are these definitive moments that happen? So one is probably the release of GPT-4 and the opening of the API to the public, to everyone. Besides that, do you think that there are also historical defining moments there?
I do think that if we are to break down the history of AI in investing, the story goes way back further. Okay, but before I do that, may I just quite simply specify the difference between what we can call analytical AI, and generative AI?
Perfect. And
because
actually,
that would help.
That will be my next question, because you also have explainable AI. So maybe we can put them and lay it down, but let's start from where you want, and then I think it's very valuable. Yes.
Absolutely. I'll start back just to make sure we're all on the same page. So AI, it's a marketing terminology, really, because there's not a real definition on what AI is. Okay, it's a different technique. We can say that if a statistical model, if a traditional model, a linear model is y, it's an equation where y equals beta times certain variables, and the human has to put all those variables together. When some of these variables are self-determined, we can call this machine learning. When a lot of these technology are working in conjunction, we can call this AI, okay, to a certain degree. Very, very, it's oversimplified, but at least it's a good place to start understanding. What is the difference between generative AI and what we can call analytical AI, often also numerical AI is referred as? They work in a similar way. The difference is that, meaning that they all try to find patterns and connection between data. The difference is that where the analytical AI is good at finding dynamics between data and between how data evolves over time, and it's used to create a prediction, a forecast on those analytical phenomena that it's looking at. Generative AI use the same example, but to create something new. That's why generative AI can create text, can create images that are never, or video that are never been produced before, right? So it's really important to understand the difference, because of course, when we work in the financial market, there's really little that you can make up. It's really very much analytical. It's really understanding how data is connected within itself, the data, all the different data dynamics, and the market dynamics themselves, how they are all connected, and how they might evolve and then adjust on the basis of that, right? When you're writing a sentence, that's where the generative AI adds value, because you have to make up something new. Okay, so that's just to be on the same page at least. So where I think was the major the major step that brought AI into investing. So the major step, I mean, it's different. It's difficult to really pin down a precise moment. But if we are to do so, in the financial sector, it has been an evolution of an understanding on how markets are distributed. Okay, and this has to do with a phenomena that it's called factor investing. Okay, meaning being able to decompose the performance of a stock, of a financial portfolio, of a company, into its underlying component, okay, which are driven by behavioral dynamics, okay, or structural dynamics. That chunk of financial understanding that happened between the late 80s and the late 90s, okay, has been really the foundation that has allowed really a strong statistical model to begin with to be developed. And that has represented probably the first generation of models in finance. This was not really AI, but these were called sometimes expert system, and was a little bit of a way to create a model that was based on certain dynamics, but could evolve a little bit. Then we have, we could say, let's say a first exploration era of the early 2000s, in which these quant models have become, really have took place. And that was not really AI, but a lot of people started to combine different models with one another to create an output that was less linear than the single algorithm. And then something happened around the years of the 2010 afterwards. Suddenly the cost of cloud computing became really, really cheap. And as cloud computing became really, really cheap, suddenly you could have models which were much more sophisticated, that could run much more data, that could process this data in a reasonable amount of time so you can do research and understand the dynamic. And that has created the opportunity really to create these analytical models that were flexible enough, could work with enough data to really benefit from the 3 decades before of these first developments. So I think that these are the most fascinating era. What ChatGPT represents just an opening to the public of suddenly I know, or I think I know, what AI is, and I can perceive it. Okay, from the investment world, asking ChatGPT which stock is best to buy is not really the best use of that type of technology, just for how they work, for this how this algorithm works. But the combination of generative AI with analytical AI represent probably the step in which suddenly this technology will really be adopted on a mass scale, because we can get into explainable AI. We can use analytical AI to produce data, forecast, prediction, understand dynamic in a very scientific and controlled way. And then we can use generative AI to create an explanation, a comment, a written comment on why the model is making certain decision and giving an explanation. And that might look like superficial, but it's absolutely not. When a doctor talks to you and he has to explain why he thinks you might have a certain disease or a certain something that's not going well, he's giving you an explanation. He's using the data, processing and simplifying the data into an explanation that you can digest. And at the same time, when doctors are talking to doctors, they're decomposing a lot of data and information into simplified information, and that's what a discussion is. Now, this is what we can do by combining analytical AI and generative AI. The analytical AI, again, creates a lot of data and dynamics. The generative AI can write comments and explanation that then the human can understand, and therefore can use that information in a much deeper and useful way. And that probably will represent the turning point in which the technology gets massively adopted.
So I think on the same line and by analogy, we've been seeing like a very similar example as what they were defining like copilots, being it like the coding copilot, or I was looking into, basically copilots helping you dig into like scientific papers by explaining to you something simplified. And I agree. I mean, I think the massive adoption will happen as an augmentation of the human capabilities, being it in the investment perspective or in the sort of the speed of learning or even coding itself. So definitely that's a huge wave. Very, very interesting for sure. So, Tommaso, are you a foundational model guy, or you think that each single sector will have their own big language model? Like, there is always the debate, like, are we going to have something which is trained on everything, able to respond to anything, or actually we're going to go back a little bit when AI kind of started, where each single one was kind of specialized? What's your take on that?
So the concept of the general computer that gives you the answer for life, which is 42 from the famous movie, what's it called, the Galactic Guide for
Hitchhiker's
hitchhikers,
Guide
the
to the
Hitchhiker's
Galaxy,
Guide, exactly. I'm not really, I don't really believe that that's the case. Just because probably I know how this model works and how information flows. Think about this. Having a deep understanding of everything, it's logically almost impossible because you are too much distracted by other information. Okay, so if you want to have a good understanding on something, and that's why people specializes and technology specializes and robots specialize to do stuff, because to really get the best out of something, there's not much point of having access to everything. Actually, that everything could actually bring distortion into how the output of something is produced. So therefore, I don't really believe that we will get to a computer that has all the information and we will all, like a god, pray to this computer, hoping to have all the answer coming through. What I do think is that there would be different technologies in different sectors, in which there would be like a verticality of application, in which the data, the information is processed in the right way. And this is, again, not because computers are not powerful enough and one day they will be, but just of how information flows. Having too much information often is not so important. And thinking that that technology can access all the information, connects all the right dots, etc., it's really sci-fi for me.
Interesting.
I don't really buy into it.
Interesting.
Even though, if I may, I've got a consideration on this, because in part we're looking at it as the way we learn. So it's difficult to transfer information from one person to another because it took years for us to absorb it and create a structure in our mind about that information. That's kind of untrue for today's AI models, right? So at the end of the day, let me simplify it a lot. There are a bunch of weights in a matrix. So you can copy and paste the weights in the matrix within a larger matrix, in a sense. So transfer of information, expansion of information is kind of an unexplored concept right now, but something that is probably, in a sense, different for sure, easier maybe than with respect to humans. So I mean, there is an open question here, but still.
No. It's a good point. A technology learns differently than how a human does. But the problem is this: when you are overflown by information, okay, the information suddenly start to overstack on top of each other. Okay, the data points become very difficult to be separated from one another. Okay, so the problem here is not just so much. First of all, let's just think about this. Nowadays, in the past, when we were hunters and gatherers, the problem was getting information. Now the problem of getting information is no longer there. The problem is making sense of information because there's so much, and you have to to narrow it down into meaningful piece, digestible piece of information. Bear in mind, this digestible piece of information is not digestible for a human. It's digestible for everybody, because you have to be vertical enough so you can really understand and dig deep into a topic. So when you have to train these models, and these models have to learn their dynamics, what happens is that they have to be able to narrow it down into the specific sector. And so how do you conduct a training in which these technology are cycling through every data in the world, understanding all the dynamic with one another? Bear in mind, these dynamics are overlapping, sometimes are double. The information is counted multiple times because that same piece of information is contained everyone in multiple places in different data. So it's really hard to think that this model could be really at their best in every single field of application. What I think is that there will be technologies that will be pre-trained, that will be like that you can almost like buy off the shelf, like pre-trained AIs that already are. They can learn dynamic, etc. But then you need to apply and verticalize, whether it's a technology that does that, but verticalize into the different sectors, in the different application. Now, if you take that AI who's been trained to do something very specific, etc., and you bring it to do something completely different, still that technology to deliver on that promise, it's really hard to do something else completely, because how you can evaluate data, it's really different. I'm going to make an example which I think it's helpful. If you train a model to play chess against itself, okay, and you just leave it there, and it plays chess and it wins all the game and it's becoming better and better, what the model knows is that the model knows that chess as an environment is a closed environment. All the information is on the chessboard. The pieces can move in a certain way. The rules are there. The rules are set. Okay. If you take that same model and you bring it to finance, or you bring it to self-driving car, he has immediately to take into account the fact that the information and the dynamic can change. It's an open environment. You're always dealing with limited information. The fact that the car did not stop on a red light, or that always stopped on a red light, that doesn't mean that it will always stop on a red light. Maybe sometimes it doesn't. So you have to take into account, you have to be way more careful. You have to be able to take into account the chance of being wrong. And that's, for example, what our algorithms at the very core do. Our algorithms in finance, they take into account the chance of being wrong. If you play chess, you don't take the account of being wrong. Or, I mean, if you do, you take it in much lesser form. Now, would that same model maybe have the same mother? Maybe that would be the case. Or father, whatever. Maybe that would be the case. But I do think that in any case, there would be verticalities of application. And there would not be a technology that you just type in and it solves everything. That's what I mean.
Yeah, totally following you. That's probably more an engineering approach than a machine learning philological approach. Look at what the GPT-4, the schematics, the engineering infrastructure that leaked a few days ago. That goes in the direction of smart engineering rather than deep machine learning. But anyhow, let's go.
Absolutely. Because at the end of the day, the problem is always the reliability, and the problem is that this happens in anything. We're always living in a world that is evolving. Think about climate change, which is just another example. Even the world as an environment is evolving. So therefore, we have to keep thinking that how information is distributed in the past, how distributed today, it's constantly evolving. So a model that learns everything, that understands everything, has to take into account also how this would affect as time changes by, and who's checking on the quality of these models. So you still would need to have models on top of models to counterfact and make sure that the model is training properly. And nowadays, these are humans doing it. Okay, in the future, there might be models training models. That might be the case. But even if you do that, How can you have even the models need to be aware of everything? So it's a little bit of a paradox. If you really dig, it becomes very philosophical, but it's a little bit of a paradox if you think how that could be possible. And that would be probably the singularity. Is it there? Is it not there? Okay, so I don't think, maybe, I don't know, maybe 100, 200, 1,000 years from now, maybe. But I cannot see I cannot see this happening at least for the next 50 years or so.
So, talking about, that's interesting because we're talking about models as if sort of there is a lineage, there's going to be a family history. So the grandpa models, and then you will have sort of the younger kids. And in one interview with the Mark Andreessen, really recent, he was saying how models basically will become immortal because each following model will include elements of the previous model. So that is something which is fascinating because then you're basically, it's not only training upon information, but they're also training upon like other models of themselves and so on and so forth. So, and there's a perfect segue actually to kind of transition to the next question that we prepared. So you started with Alice, which is kind of the grandma of Sphere. So I was wondering how exactly you guys like evolved from one model to another. How did it go? And yeah, I mean that's fascinating. Probably how the offspring, how you gave birth actually to the new
Absolutely.
kid on town.
One thing that we have to remember is that as humans develop tumors, algorithms develop tumors as well. So they sometimes get trained and get in a direction which is not exactly right. We're always very positive and thinking innovation is the future, but we have to think that that dynamic that you just described of modeling evolving, there's also the dynamic that they're evolving not in the right way. And so sometimes, a Darwinian approach to modeling is actually a good one, the best which is able to fit. And ultimately, you have to take into account the fact that you don't want to have models to develop internal loophole, because at the end of the day, every model, how it works, it's a mathematical minimization, right? Behind the curtain of what we see, there's somehow function that are getting minimized. Okay, so mathematically speaking, you don't want the model to get stuck in one minimum in a point in which it thinks there's an efficiency, but the world has evolved and that stays put. It has to be able to evolve in all the single components. So it gets really deep here, but I just want to point out that there's a dynamic that needs to be controlled on how models are not being stuck in one point, which might not be true forever. Okay, so that's the first thing. How have we done it so far? So first of all, how does it work? We have developed ALICE, which stands for Adaptive Learning in Complex Environment, which is our true core deep backend, which still is true. And then we developed Sphere. Sphere represents the interactability of ALICE. So it's not that we completely killed ALICE and developed Sphere, is that just through Sphere, we can access ALICE in a much better, smoother, and interactive way as users, really.
So you took Alice, and then it was a makeover plus send her to college, and then let's come back, and then you're ready to go for the next phase of your life.
Exactly. Put a little bit of cosmetics. That's what it is. Yes. At the same time, though, Alice itself has kept evolving. And of course, we had generation. We had generation of different technology. We've implemented new models. And the real dynamic that we realize it's really core, it's the same tumor example that I was making before. As these models are evolving, you always have to ask yourself, yes, the output is better, okay, but how can we make sure that there are not dynamic that maybe we will see in a certain period of time that are actually counterproductive? And so there's a lot of theory on how to do that. And especially there's a different thing. If you have a model like an artificial intelligence that does generative AI, it's fascinating. It produces images, video, audio, the sentences, fantastic. But if you're talking about analytical AI, which is most likely the technology that's going to read your scan to see if you have a lymphoma, if you have if you have a problem within your body, if you have a brain tumor, that's going to be an analytical AI. You want to make sure that moment, if it fucks up a little bit and a sentence is not perfect, okay. If that model fucks up a little bit, it's life and death. Okay, so there's a lot of theory on how to make sure that these models are evolving, but at the same time they're not developing. They're not getting stuck in some past beliefs. That's what we can see. And so therefore, sometimes the evolution, it's really killing the mother or killing the father
No,
to make it a better offspring.
But you actually sent Alice to therapy, so she's not stuck with the past, and we're like her mother issue or daddy issue, and then she can move forward. Super interesting
But in
way.
fact, look, I wanna throw this in. A lot of the time, we think that this model have the ability of learning new things like never before. But often, a great capability of model is, compared to the human mind, is having the chance to forget.
Interesting.
We struggle to forget about stuff. A model can forget just because you take away the data. Okay, so forgetting sometimes it's more important than remembering, and this has to do a lot on how models are developing in the future. And again, we cannot talk about artificial intelligence if we don't get into the philosophical element of how this technology learns. But think about this: having the ability to forget sometimes is better than having the ability to learn.
Wow, that's it's like a pearl of wisdom. Exactly. Like this goes beyond definitely the topic, but super interesting for sure. So, talking about Sphere, let's maybe dig a little bit deeper and try to look under the hood and really the results of the application of Sphere that you guys mentioned in your case studies with by working with clients. They're pretty impressive. So, just to mention a few, 20% lower portfolio turnover, essentially meaning that the intelligence is really good at helping basically picking the right stock for a long-term strategy. 35% more average Sharpie ratio, so a better risk management for sure. And then an increase in annual returns of between 84 and 160 bips, which is massive, talking about big numbers. So the end result is impressive. Let's now look under the hood, actually try to look into the soul. So the heart and the soul of Sphere, they kind of rely on two big concepts, which is one is non-chronological learning, and the second one is the hidden Markov models. So maybe let's, it's getting a little bit technical and see exactly how you guys sort of, develop these two approaches, because they're also there is a big parallel in one of your paper where you kind of make it a parallel with human intelligence and how investors learn by experience, data analysis, but also by sort of combining those data and outputting interesting takes on the economy, on the macro situation, etc. So let's maybe look into these two big elements, which I thought were very, very interesting.
Absolutely, and I think that this kind of helps to put all the things that we said before into something concrete. First of all, you point out one thing that it's always striking. On average we had on the type of analysis that we conduct to produce this data about 20% lower turnover. What this means is that our AI, talking about the chance of being wrong, takes into account better the chance of being wrong. And this has to do with what I told you before: open environment against closed environment. Open environment is chess, is image recognition, is writing a sentence. There are ground truth. There are boundaries within your system that and you can trust your model. You can just look at the result. Finance is an open environment. You're always dealing with limited information. Even if you have all the data in the world, it's always limited information, because there'll be outside information that has never happened before, a war, a new dynamic that's coming in. So it's really important, not just that you're right, but that you take into account the chance that you're not. And by, the lower turnover, meaning that the portfolio are not moving randomly to one side to another, it's really happening because of this specific dynamic, and it's really critical. And the way on which we've developed, it really stands on those two pillars: non-chronological learning and regime analysis, to be able to have these components. Before I get into how they work, we made an analogy to the human mind. Why? Because finance is not solvable. Okay, so whereas recognizing something or just creating a video is solvable. Now myself, I'm talking on a screen. It's a series of pixels that go from the top to the bottom of my screen that are colored in a certain way. It's solvable. You can get to a point in which you correctly color each pixel in the right, and you make a change in the right manner, and you can completely create a fake video of myself doing whatever you want me to do, or someone else. This is a solvable problem. Okay, finance is not a solvable problem. Finance is an open environment, can never be solved. It's a market where assets and wealth is transferred, and opportunity are. There's always one that thinks is a bad opportunity and someone that thinks is a good opportunity. Otherwise, nobody would buy and sell anything. So because it's an open environment, and it's not a solvable one, the reason why there is an analogy with the human mind, it's because you have to take into account how to process data with very limited awareness of everything going on around. And so the way in which we do it with these two dynamics. First of all, it's what we call non-chronological learning, which effectively it's a way to cluster information, to cluster different examples of market dynamics, individual market dynamics, detailed one, that have happened in the past. Okay. Then we use neural network to cluster them, to bundle them together. And then the assumption is maybe history for sure will not repeat exactly the same, but maybe some of the dynamics that have happened in the past might, in a different combination, happen again, or at least a portion, 50%, 20%. And so with non-chronological learning, breaks down the time sequencing of event and looks at events as a whole. And so we can then look at the scenarios of today and see if we can find some of these, combine them together, and that represents the way in which we can create forecast. Okay,
so you
basically that's the very first component.
You pull out patterns of behavior of certain elements, clustering them together with that's an unlabeled data sort of modeling, and then basically that's the foundation for everything you do when you assess a scenario, and whether you basically give recommendation from it, right? So my understanding, correct me if I'm wrong, the idea is that through non-chronological learning, then you kind of build like a sort of an optimal benchmark, and then from there you give assessment whether my portfolio is like overweighted on certain asset, underweighted. Is it like roughly the idea, roughly the structures, or there is some more moving parts?
Yeah, so it is kind of like, more than creating a benchmark, what we do with the non-chronological learning is that we can assess if certain market dynamics that we're seeing today have somewhat in detailed way happened before. And that represents, more than a benchmark, a way in which we can forecast expected returns and the variance and covariance matrix, how market could evolve. Okay. And to make an analogy that maybe for a wider audience it's easier to understand, think about self-driving car. Self-driving car, it's an open environment. Why is it open environment? Because it's always dealing with limited information. Think about this. If there's a street and a car on that street overtakes the other one, that doesn't mean that every time there are two cars on that street, there will be an overtake because it's convenient. Maybe there is this, maybe there's not. Maybe it depends on condition. Maybe that day was not raining. If it's raining, that's not happening. Maybe that information happens somewhere else. Okay. So what we try to do with the non-chronological learning is decompose all these events: an overtake, a weather condition, a crossway, and we try to bundle them together and then look where we are now and look at all the possibilities that might happen, considering to where we are. We associate probability, and on the base of that, we can create a little forecast on what might happen. Okay,
Beautiful.
Given condition, etc., etc. That is what we think might happen. Now that represents the non-chronological learning. Separately, we have a different component, which is what we call the regime analysis, which we do through a completely different technology, which is called HMM, Hidden Markov Model, which is different. The HMM helps us to assess the risk scenario in which we're in. Just risk. We're not interested in return in this picture. We're not interested into assessing how markets are evolving from that standpoint. We're just assessing the risk scenario. Why is it really useful? It's really useful to do two things. Firstly, to have an understanding, a general broad understanding on risk condition in the market, okay? To size opportunities for sure. But then secondly, to put a challenge on our own metrics that we can produce, which is if risk or certain dynamic, if there's a moment in which risk is very, very high, maybe the way in which we project our own expected return and we forecast the future market scenario, we can be more or less confident. Okay, and the way in which we could do it is basically simple: is we can check in similar risk scenario how different dynamics have evolved, and then we can measure in this stage how these are evolving today. Are we precise? Are they moving in the same way or not? And then adjust on the base of that. To make it again an analogy on self-driving car, which I think it's relatable, it's almost imagine that we have a way into assessing panic on the road. Okay, because maybe there's an earthquake. Okay, suddenly your model that it's able to drive well in all the different cars, in all the different conditions, which is rain, sun, snow, whatever, suddenly has an earthquake. When an earthquake is around, people are more stressed. Okay, or the street is bending because of the waves of the earthquake. So by having a view on risk, if you can measure stress in people, or people are just randomly crossing the street where they're not supposed to, suddenly you can be way more cautious on your prediction. So in a moment in which the self-driving car is predicting certain events, it can be more cautious on how this event might outcome and be therefore more conservative or capture opportunities that might not be there. For example, someone is braking, then you would overtake because maybe it's dangerous that it's stopping too quickly, etc., etc. So the two components create a very dynamic model and framework that it's used to do what? To create portfolios, asset allocation, to evaluate how our portfolio is positioned today and how it might evolve in the future, and so on and so forth.
So the beauty of the hidden Markov model, the HHM, is basically the fact that there is a good way to take into account all these hidden factor, hence hidden Markov models, that actually is very fruitful, and then you can include in the model, and then the model can learn from it, right? So I think the earthquake example is very good, because then it kind of takes into account something that the model didn't see before. And so to translate that into the finance world, that's also a way to sort of take into account situation that didn't align exactly on what was happening before. So there is this forward-looking, evolving sort of learning sort of attitude, right? I'm trying to generalize here.
You're absolutely right. And of course, we're making a lot of simplification because
Sure.
these are very complex dynamic, but you're absolutely right. And on top of this, it's an unsupervised machine learning techniques, meaning that you have not defined ex ante, so beforehand, what is the scenario that you want to detect.
Exactly.
Okay. But it finds it by itself. I can get into the math on how it works if you want. But the beauty is that there's not a human bias, and also that anchoring on how a scenario looks in terms of risk. Think about an earthquake. On what an earthquake is, you would have to define what an earthquake is. Okay, and maybe earthquake have different forms, ways, maybe you can model all of them, but most likely you cannot. And so by having a model that self-learns, if earthquake became suddenly because, I don't know, the environment changed and maybe how earthquake happened suddenly is a little bit different, they would still be able to pick that up, and the model would adjust to that dynamic because it's not anchored to a definition of what an earthquake is or what the risk scenario is in the financial market. And so it makes it much more adaptive.
And by analogy, can you give us like a practical example of the earthquake in the finance world? Is it like a war, unexpected war? Is it like a nuclear bombing? Is it like, what is a good like sort of parallel to that?
Yeah. So on the contrary, like what people think, like extreme event like a war, like COVID, etc., those are quite easy to be detected, right? Because these are, it's quite obvious what's going on. At least, of course, it's impossible to predict them. Okay, it's impossible to predict. The black swan event exists because they cannot be predicted. So I just want to point that out. But it's quite, I wouldn't say it's easy, but it's easier to react to these events. What it's difficult, it's actually to understand if something underneath the surface is happening, which is exactly what happens with earthquake. The real challenge with earthquake is not really detecting when there is one big massive one that everybody can spot, but it's actually how can I detect micro vibration in the ground that can potentially lead to an earthquake. That's the real interesting piece of information. So for us, the regime analysis is really being able to spot within how different actors in the market are moving and therefore they are creating almost like ripples effect that maybe we cannot pick as a whole, as one, but by linking them together, we have a certain dynamic which is suddenly something beneath the surface is moving. Maybe an earthquake does not happen because, again, maybe it does not happen. But at least I have a deeper way to look at this dynamic happening. This is the best example I can do, at least for a general audience. If not, we can get much more specific, but it has to be really drilled down in finance itself.
I love it for sure. Let's keep on with the car analogy. So in the car industry, we talk about level 5 self-driving sort of level where the human are just passenger. They don't give a crap. They just are like there. Are we gonna reach a level 5 in investment? I mean, where the human element is completely like standoffish. The AI is doing all the job in allocating, in assessing risk, rebalancing portfolio, and so on and so forth. This is a question that I wanted to make just a transition on the role between, AI, human. Is it combined? Do we see the combination as more powerful, or a little bit provocatorily, like let's have an AI doing all the job of the investor?
So I do think that it's a very good question, and it's a very good. There's a lot of philosophy on how this might play out in the future. I don't necessarily think that AI just by themselves playing one against the other will be the future. I do think that the human plus AI will be in the equation, and the reason why it's because there is greed that plays a role. Okay, and whereas if we are all passengers of car, I do not really care that much if I get there 5 minutes before or 5 minutes after. I just sit on a car. I don't have to drive. I make a phone call and it's fantastic. What an experience. And everybody's kind of happy with this. And then the system would self-regulate to make sure that there are not too many queues. So if there's because think about this, if everybody suddenly is rush hour, everybody wants to go home. Fantastic. Hopefully one day AI, self-driving car 5, 6, 7, whatever the generation would be, they would not go all on the same street, right? They will self-regulate so that they would use different streets so that the traffic is not too bad. And everybody kind of gets there in the least amount of time. Some would get there sooner, some a bit later, but it's kind of fine, okay? In finance, there is greed. And that's there. And I don't see that disappearing. And so therefore, you want to get at home sooner than someone else, because that makes a huge difference. And so that element of greed would always create different opportunities. And therefore, the way in which greed is distributed, and I'm not saying that there are people that are more greedy than others. I'm just saying that there are institutions and because people in finance always think about the retail person, myself, somebody on the street. But it's really big institution, pension funds, big asset managers, big wealth, sovereign funds, etc., allocating their money. So these institutions, have different objectives on how, when they need the money, why, how they're trying to do it. And so by how their different greed level plays out, that creates differences. And so I do think that to assess that greed, the human would always be in the picture.
Interesting.
The AI will help a lot on make it much more efficient, on to capture those dynamics, and therefore the opportunities will become slimmer and slimmer, and you have to be able to really work within a ton of data to find little nuggets. But that's why I think that human and machine will play together, because just technology by itself at a certain point would be like otherwise just like driving cars, and they would self-regulate to a certain extent.
No, that's awesome. Having said that, let's talk about the institutional adoption of AI, which I thought was very, very interesting. So more and more institutions are looking into AI, and basically you point really well out basically on how each step of the institutional investment process, literally from strategic asset allocation to tactical asset allocation to portfolio construction, there is always a specific AI application, and you kind of made us visualize it through your website, where you kind of show the investment process without AI versus the investment process with AI, and it's pervasive. It's in every single step of it. So how do you see institution adopting this new technology? Do you see that they're more sensitive on maybe some specific aspect of the investment process, or is it like a sort of a blanket adoption where if they want to go in, they just go in on everything?
No. They're dipping their toes. They're dipping their toes into the water because, of course, this is new for almost, I wouldn't say a very large part of the industry. And the reason being that quant model has always been around, right? But the difference that represents AI, and this is something that I truly, truly believe in, is the ability to suddenly connect the human mind with the statistical approach into a quantamental framework where it's what I keep referring to as assisted decision making. And the reason why you can do it now, it's because AI, compared to a traditional algorithm that just spits an output and that's it can react to how you see the world. And so therefore it can change its output on the it still has its own point of view, but it adapts a little bit the output to fit better to what you think, to get to a better combined output. So that's the real value. So this is something new. This is not something that was done before, and making sure that a technology and a human work well together, it's easier said than done. So that's why I said that they're dipping their toes, because from organization to organization, we see that, and it's really a cultural element on how they're doing, but they're trying to understand how can I input, how can I add within a process that could fit basically everywhere, but what's the best way to start? Then once they get confident on that, and they learn how to do it, then suddenly they pick up the pace and they wanna broaden the spectrum, integrate it more. That's the pathway to adoption that we see. I have to say, but it's similar to every new technology. It's the same thing with ChatGPT. At the beginning, people started writing jokes, started immediately testing where it was wrong. If you were asking anyone when ChatGPT was released, did you try ChatGPT? The first thing was yes, and it failed over here. Right? That was the immediate go-to. Everybody was like, yes, and I tricked her. I saw that it's not perfect. Then suddenly people passed that phase and start looking with a much more open mindset and thinking, oh no, let me try to do this little piece, which maybe is, revising a text or summarizing whatever document. And now suddenly these are the application. This is the same pathway of adoption that we see in institutions, really across the globe. It's not different from the US to Europe, where we have clients in both of these geographies. It's pretty similar.
Interesting. Let's jump maybe into a case study that you can share with us of one very significant application of Sphere and how you guys are working with institution, just to give sort of a practical ground. So let's go back to on the ground.
Absolutely. So a good example is what we're doing with a large asset management company in the US, and we're doing the same thing actually with a even larger here in Europe, which is this. A lot of these institutions, they don't just manage one portfolio, they manage multiple portfolios. So what they're using Sphere to do is basically manage this portfolio better at scale. So what happens is this: they use a Sphere as the central engine, we could say. They plug into Sphere their own market views, the way in which they see the world. And to make an analogy with the self-driving car, what I think is the best way to get home quicker than someone else. Okay, that gets combined with the way on how Sphere thinks it's the quickest way to get home. Okay, gets blended in, meaning it finds the path to get from work to home in the least amount of time. But then it doesn't need to drive one car. It needs to drive multiple cars. So then what Sphere does is it gets all the different portfolios in, okay? And of course, these portfolios are different. They've got different asset classes. They've got different investable universe. They've got different constraint and investment objective. But the view on how you get sooner to home is to avoid traffic is similar, right? And so what happened is that Sphere would optimize for every portfolio what is the best allocation for each one. So gets the portfolio and suggests different rebalancing on how to tweak it, what to buy, what to sell, to make sure you get the best out of that view. And I make the analogy with the self-driving car because I think with the driving, with self-driving or whatever, even Google Maps helping you to get home, because I think it holds true. Think about this. You have your own ways on how to get faster at home. You combine it with the data of Google telling you, look, based on now where we are, the traffic, etc., that's the best way. But then you're in charge of a different, or like a fleet of cars. And some cars have to stop. Some cars have to stop along the way. Some cars need to refuel. Some cars are electric. Some cars are, let's say, diesel. And you also want to optimize on how much gas you use. Okay, so yes, the best pathway to get home is that one based on traffic. But then every car might have a little, deviation because it has a little bit of a different need. Okay, that's what we do. Based on the same view, we manage our clients are using Sphere to manage multiple portfolios in a very controlled way.
Super interesting. So we're about to touch the hour. On the concluding notes, what I was thinking is actually maybe try to unveil a few of the challenges that are going on right now for this kind of AI adoption in investing, and maybe what is the future hold us for. I mean, what is going to happen in your view? What's going to be the next big thing that people should take a look at?
So the challenges of adoption is the adoption of a new technology, which is, this is something I've learned when I was at Google, which is the greatest competitor of any new technology is the status quo. It's just people are used to do ways in a certain way and takes a little bit of time for people to change. So that's I think it's the greatest challenge, because all the others, and probably, from a technical standpoint, making the explainability even better. And this is where generative AI, as I was saying before, generative AI, analytical AI can play a role together to make that explanation even more snappy, even more clear, even more to the point, and then you can react to that information. So that is the two things that can really help to really drive the massive adoption. Where do you see the future? I mean, for the broad application of AI, which is just a more powerful math, which is more flexible than what we had before, I don't see this not being adopted everywhere. So, the only element that I see is that if I have to go 5 years from now, I think there will be within different sectors, there will be vertical AIs, a few of them that will be customized to different clients' needs, etc. But the problem is that these technologies are evolving so fast that companies have to look at AI as as building blocks that they can take, integrate, and use, because they don't because of the speed of this technology, nobody has, apart on who's doing it, have the capability of keeping up with the pace. Think about this.
Interesting.
Do you
Very
want to
interesting.
develop it yourself, a new LLM, a new ChatGPT? No. Maybe if your focus is just ChatGPT, maybe you want to do it. But if you're a company that does, if you're General Electric, developing your own LLM makes no sense. You will never be as fast as the other. So it's much more important that you would use components that are out there. Some of them could be or are open source even in the future, so that might open up for new opportunities. Okay. And so the key of the game really how I can be a builder, like an architect, and how I can use different components to create ultimately something new, which is what happens with a lot of other things. If you think about coding, back in the day, coding was I write everything myself, and back in the day was a bunch of zero and ones. Nowadays, being a coder is almost like being a builder. There's a lot of bits that are already been built, libraries, etc. So that I think that's going to happen as well.
Yeah, I agree. Sounds like the web again, just in AI.
Again.